Assalamualaikum warahmatullahi wabarakatuh. We are from group SABS and today we would like to present about recycle brine tank for interconnected tank. I'm Shikin and I will introduce the definition and the objectives of this topic. A brine tank is a reservoir or a container which holds high concentrated solutions of potassium into brine solution. A recycled brine tank system means no salt lost in this system. So for the objective, we need to establish a connection of two brine tank systems using first order differential equation. Then we need to solve the system using variation of parameters and matrix exponential methods. The last one, we need to determine the changes of salt concentration in each tank.
Hi, I'm Syafiqa. I will introduce our mathematical model, which is a cycle brine tank for interconnected tank. As stated in problem statement, the initial state of salt in both tank X and tank Y is 30 kg. Hence, we are required to find the final concentration of salt in tank X and tank Y. Manually, we can calculate this problem using metric. We are required to find the eigenvalues. Once we get the eigenvalues, we find the eigenvectors. As this problem is a homogeneous linear system, we proceed to next step where we are required to find partial equation using variation of parameters. As we get the partial equation, now we can find the general solution for both tank X and tank Y.
Hi, I am Noor Hidayu and I will be continuing the discussion on the result from computer generated. In order to find the computer-aided solution, we compute the ODE by using the MATLAB. We insert the coefficient matrix and the non-homogeneity from both equations to get the general solution. Then, we insert the initial solution to find C1 and C2. After that, we plot the graph. Based on the graph, the red line indicates the concentration of salt in tank X. The red line seems to be declining exponentially. It shows that the amount of salt concentration in tank X has been decreasing. On the other hand, the blue lines represent salt concentration in tank Y. The lines is gradually increasing, which shows that the salt concentration in tank Y has been increasing. To summarize, the first-order differential equations can be applied in the connection systems of two brine tanks. Secondly, the changes of salt concentration depends on the water flow in and out between both tanks. And third, no salt is lost in the system as it is a recycled brine tank system. As a recommendation, by increasing the amount of time, both tank X and tank Y will have a balanced salt concentration. Secondly, by reducing the volume of mixture or fluid in tank Y, less time will be taken for concentration of salt in both tanks to be optimal. That's all for the topic of recycled brine tank systems. Thank you for watching. Bye!